This is the Triangle Inequality Theorem worksheet. So the first half of this worksheet is on the Triangle Inequality Theorem, and then the second half was review questions for the Unit 3 test. So let's start with number 1. So it's asking us to state if 3 numbers can be the measures of the sides of a triangle. So again, just to recap, if we have 3 sides, A, B, and C, right, A plus B has to be greater than C. B plus C has to be greater than A. And A plus C has to be greater than B. Okay. Any 2 sides of the triangle are going to have to add up to more than the length of the third side. So the length of 2 sides have to add up to more than the length of the third side. So number 1, they're giving us lengths of 6, 6, and 5. Okay. So the length of the first 2, which are 6 and 6, have to be greater than the length of the third side, which is 5, and it is, because that is 12 is greater than 5, which is true. So we take the next 2 sides, so 6 and 5 have to be greater than the third side, 6. Right? If we had a triangle, right, we would have 6, 6, and 5. Okay, and we know 11 is greater than 6, so we're good. Right, and then we have to pick our next set of sides, which is going to be 5 and 6, which is greater than 6. And again, 11 is greater than 6. So can we have a triangle? Yes, because any 2 sides that we picked are greater than, right, there's 3 different combinations of sides, right? We can do 6 and 6, 6 and 5, or 5 and 6. Right, in all those situations, those 2 sides are going to add up to more than the length of the third side. So this is yes, we can make a triangle. Okay, number 2. Okay, number 2. Our sides are 3, 10, and 7. So we add our first 2 sides up. They should be greater than 7, and it is. 13 is greater than 7. We pick 2 other ones, so let's pick 10 and 7. Those have to be greater than 3, the third side. So 17 is greater than 3, so we're good. Okay, our last combination, 7 and 3, has to be greater than the third side, which is 10. So we get 10 is greater than 10. And we know that 10 is not greater than 10. 10 is equal to 10. So this one doesn't work. Since it doesn't work, we know that no, we cannot get a triangle. Cannot make a triangle. If you try to make a triangle with these numbers, if this was 10, right? If you had 3 and 7, right, they wouldn't be able to meet. Okay, the place where they would meet would be right here. This would be 3, and this would be 7, but you would notice that we don't have a triangle here. We just have a line. They would meet, they would form down together. That's a terrible idea. They would form together. They'd form a straight line, right? You wouldn't see the triangle. As they came together, as those 2 sides, length 3 and 7, came together, they would converge on top of the third side. And since they're on top of the third side, that's not going to be a triangle. So no, it has to be greater than, and it's not. All right, number 3. Seven plus 2 is greater than 5. That's going to be true. You're going to get 9 is greater than 5. 2 plus 5 is greater than 7. So we get 7 is greater than 7, and we know is 7 greater than 7? No, 7 is equal to 7. So this is not going to work. We don't need to even try the next one, because the Triangle Inequality Theorem says any 2 sides that you pick will add up to more than the third side. So if just one of them doesn't add up, one of the two pairs you pick, one of the pairs you pick does not add up to the third side, then you know you cannot form a triangle. So again, this one is no. And 4. Okay, 2 plus 8 is greater than 5. Yep, 10 is greater than 5. 2 plus 5 is greater than 8. So 7 is greater than 8. Nope, clearly 7 is not greater than 8. So again, this one is also no. So that's the first type of problems you may encounter with the triangle inequality theorem. Probably the easier set of problems. We go down to the next ones. So here are two, they're giving us two sides and they want us to find the possible range of measurements for the third side, the possible range of lengths for the third side of our triangle. So I'm just going to call the third side of our triangle x. Right. So the proper way to do this, there's a quick way that doesn't really demonstrate that you understand the concept, and then there is a full good way of doing it, full explanation. So we're going to do that way first, and then I'll show you guys the shortcut. So any two sides have to be greater than the third side. So 25 plus 38 has to be greater than x. So 63 has to be greater than x. We also can do these two. So 38 plus x is greater than 25. Subtract 38 from both sides. X is going to be greater than negative 13. The third set we can do is 25 and x. So 25 plus x is greater than 38. Subtract 25 from both sides. X is greater than 13. Okay, so we have x is less than 60, so we can rewrite that as x is less than 63. We have x is greater than 13. And x is greater than negative 13. So negative 13 to 13. We have to pick which range of possible x values you have. So what x values fit all three of these inequalities? So since we only have one less than sign, we know x is going to be less than 63. Okay. But if we look, we have two greater than signs. 13 and negative 13. So x has to be greater than 13 and x has to be greater than negative 13. Okay, we want an x value that fits both of those inequalities. Right, so x is greater than negative 13 and x is greater than 13. So what set of numbers is going to be greater than 13 and greater than negative 13? Okay, that's going to be numbers that are greater than 13. So we want x to be greater than 13, right? If you pick a number between negative 13 and 13, like 5, right? 5 would have to work for all three of the, if we said x equals 5. We're saying that was one of our possibilities. 5 would have to work for each one of these. So is 5 less than 63? Yes. Is 5 greater than 13? No. So we know 5 can't be a possibility. So even though 5 is greater than negative 13, it doesn't fit all three. So we need numbers that are greater than negative 13 and greater than 13. So we need numbers that are greater than 13. It's like you guys should have done intersections. So what's the intersection of x is greater than 13 and x is greater than negative 13? The intersection of those two inequalities is going to be numbers that are greater than 13. So this would be our answer, from numbers between 13, greater than 13, and less than 63. Okay. The quick way to do it, okay, we add them together. Gives us 63. So we know x has to be less than the number we add them together on. X has to be less than 63. And then if we subtract them and take the absolute value, we know it's got to be greater than that number. So if you take the difference, it's got to be greater than the absolute value of the difference. Greater than the absolute value of the difference. And less than The sum. So it's 5. Okay, so 6, 28 plus 40. Again, we'll call this x. The third side we're going to call x. We're trying to find what values of x are going to work to make a triangle. What values of x can we have to make a triangle? Okay, so 28 plus 40 is greater than x. That gives us 68 is greater than x. Greater than x. Then we have 40 plus x is greater than 28. So we did 28 and 40. Now we're doing 40 and x. So subtract 40. X is going to be greater than negative 12. Then we can use 28 and x. So 28 plus x is greater than 40 minus 28. X is greater than 12. So we need a number that is less than 68. Okay. So we have x is less than 68. We have x is greater than 12. And x is greater than negative 12. So just like the last one, we need a number that's greater than 12 and greater than negative 12, which means that number has to be greater than 12. So x has to be greater than 12, and x has to be less than 68, right? We could write it like this: x is greater than 12, and x is less than 68. Or we can put it together all in one expression. Okay. Again, the quick way: 28 plus 48. 28 plus 40 is 68. 40 minus 28 is 12. But again, if you do it that way, it doesn't really show that you understand what's going on at all. Okay, that's just a little shortcut. A big shortcut, really. All right. Number 7, 45 and 40. Again, we want to say x is our third side. Again, you can make it whatever you want. Okay, we know right away our answer should be x is going to be less than 85. All right, 45 plus 40 equals 85. Okay, and then we know 45 minus 40 is 5, so we know it's going to be 5. So we know that's our answer. Okay. All right, and that makes sense because 45 plus 40 has to be bigger than x. Right, so 85 is greater than x, right? And that's right here, right? We just have it written the other way. So if we flip it around the other way, x is less than 85. Right here in this part of our equation, that's where x is less than 25. 85 is coming from, right from our triangle inequality theorem. Okay, and then we have 40 plus x is greater than 45 minus 40 minus 40. X is greater than 5. Then we have 45 plus x is greater than 40 minus 45 minus 45. X is greater than negative 5. So again, we need numbers that are greater than 5 and greater than negative 5. Right? So if you pick the number between there, like 2 is greater than negative 5, but it is not greater than 5. So we need to stick with greater than the bigger number, greater than the larger number, which is 5. And that right here is where x is greater than 5 comes in, right? So if we wrote this the other way, x is greater than 5, right? X is greater than 5, that comes right in here. And if you notice, we subtracted, right? 45 minus 40. So you can certainly do it this way, but I'm just showing you so you know what you're doing. You're not just putting random numbers down because that's the process. Okay, that's 7. Let's do number 8. number 8. Again, we can add them together. So 50 and 33 is going to be 83. So we know we have to be less than 83, and then we know 50 minus 33 is 17, so we know it has to be greater than 17. Okay, but let's do it out so we know what we're talking about. 50 plus 17 is greater than x. So again, our third side is x. You make it whatever you want. You don't even have to put it in, but it's probably better if you do. So 50 plus 17 is going to be 67. Wait, what? Sorry, 50 plus 33. 50 and 33. So then we're going to add them together and we get 83 is greater than x. Or, again, same thing, x is less than 83, right? X is less than 83, but 83 is greater than x. That's where this is coming from. 33 plus x is greater than 50 minus 33. X is greater than 17. Okay, and again, that's where our x is greater than 17 comes from, right? If we do the last one, we have 50 plus x is greater than 33. Minus 50, x is going to be greater than negative 7. So we know it's got to be greater than 17, which is, again, x is greater than 17. But it's opening up to the x. So x is greater than 17. X is between 17 and 83. Any number. 20, 50, 42 and a half, 82.5, 81.6, 82.9, 17.1. Any number between there you could use to make a triangle. Right? Again, that's what we're doing here. We were trying to make which numbers, which values of x, which values for a third side, which we called x, would make triangles. Okay. Number 9, we are trying to find which side is the shortest. So shortest to longest. So we need to find the measure of all the angles first. So the measure of angle C plus, right, the measure of angle C plus 68 plus 80 is going to equal 180. The triangle sum theorem tells us the measure of all 3 interior angles of the triangle add up to 180. So the measure of angle C plus 148 is 180. Minus 148 from both sides. The measure of angle C is 32. We asked ourselves which angle is the shortest. 32 degrees, or which angle is the smallest, and 32 degrees is the smallest. So angle C. So we look for the side that is opposite angle C, which is AB. So AB is the shortest. Our 2 angles left are 68 and 80. So 68 is less than 80, so 68 is our next shortest angle. So we look across from 68, which is from angle B, which is 68 degrees, and we have AC. And then our longest angle is 80 degrees. So across from 80 degrees is BC. Number 10, we have angle F is 50 degrees. The measure of angle F is 50 degrees. The measure of angle E is 65 degrees. The measure of angle G is 65 degrees. So angle F is the smallest angle at 50. So we look at the opposite side, which is GE. So GE is going to be our shortest side. Okay. And we notice we have 65 and 65. So it doesn't matter what order we go in, they're going to be the same. So we can put the opposite side from angle G, which is EF. And then put the last side, which is opposite angle E, which is GF. All right, and those could be switched. You can put them on top of each other or something. Either way, that's fine. Okay, number 11, smallest angle is 33 degrees. So our shortest side is opposite of our smallest angle, right? 33 degrees is our smallest angle. So opposite of angle Z is going to be XY. Okay, now we look for our next smallest angle, which is 53 degrees, which is angle Y. So opposite angle Y is side XZ. And then we look for our biggest angle, which is 94 degrees, which is angle X. And opposite angle X is going to be YZ. And number 12, we have an equal angular triangle, which means we have an equilateral triangle, which means all the sides are the same length. So PQ, PR, and QR are all going to be the same length. Okay, so PQ, QR, and PR are all the same length. All right, so that is the first half of your sheet. Oh, we have more. Never mind, we got a few more. Okay, guys, just skip ahead in the video if you're, obviously you shouldn't watch what you already know if you already get it. But so just like the shortest side was across from the smallest angle, the smallest angle is going to be across from the shortest side. So we have sides 14, 13, and 20. Smallest side is 13, so angle Y is going to be the smallest angle. 14 is our next smallest number, so we go opposite, which is angle X. Then our largest side is 20, so our largest angle is going to be angle Z. 14, 10, 16, and 9. Smallest side is 9. Opposite of 9, which is SR. Opposite of SR is angle Q. 10 is our next shortest side. So opposite of side of 10, which is side QR, is going to be angle S. Okay, and our longest side is SQ, which is 16, and the opposite of SQ is going to be angle R. 15, 13 is our smallest number. It's our shortest side. So angle D across from our shortest side is our smallest angle. So angle D is our smallest angle. Then we have 17. Across from 17 is angle F. And then our largest side is 25, which is FD. And opposite side FD is angle E. Again, smallest side, shortest side is 12, so our shortest side is CB. Opposite CB is angle A. Our next shortest side is AB, which is 21. So opposite AB is angle C. And then our longest side is 23, which is CA. And then opposite CA is angle B. Okay, so that's the end of the first half, which is should have been turned in on Thursday, November 29th. And then we are going to work on the second half, which is review material for Unit 3 test on Friday, November 30th. The first review question we have is you assume that AB is congruent to CD. So let's put our hash marks in. AB is congruent to CD. And BC is congruent to DE. What additional information would you need to prove that triangle ABC is congruent by triangle CDE by side, side, side? So the side postulate tells us that if we have 3 pairs of congruent sides, then our triangles are going to be congruent. So in order to prove that the triangles are congruent by side, we need to show that there are 3 pairs of congruent angles. There's 3 corresponding, or sides, I'm sorry. 3 pairs of corresponding sides that are congruent, right? Side. We need three corresponding sides to be congruent. So we have AB is congruent to CD, and we have BC is congruent to DE. So far we have 2 sets of sides that are congruent. We need to find the third set, which is going to have to be the third side of our triangle. So we're going to have to know that AC is congruent to EC, or CE. Sorry. Either way would be fine. Okay, so we need to know that AC is congruent to CE. Or you could say we need to know that C is the midpoint of AE. That would be fine as well. One of these 2 answers, both would be great. The second part is asking us same setup. So we assume that AB is congruent to CD, and we assume that BC is congruent to DE. And it's asking us what additional information would you need to prove that triangle ABC is congruent to triangle CDE by side, angle, side. So if we wanted to prove that they were congruent by side, angle, side, we would have to know that 2 sides were congruent, 2 corresponding sides were congruent, and the included angle was congruent. So the included angle means the angle between the 2 sides. So in this case, we have 2 pairs of congruent sides. So AB is congruent to CD, and BC is congruent to DE. Right? We need the included angle, so the angle between the 2 sides to be congruent. In that case, this is angle B and angle D. So we would need to know that angle B is congruent to angle D in order to show that the triangles were congruent by the side, angle, side postulate. So we have to fill in what missing piece we know, right? For the first one, we know we have 2 congruent sides. We want to get side, so we need to know that AC is congruent to CE. The second one, same thing. They're giving us 2 corresponding sides that are congruent. We want to know what we need to know in order to prove it by side, angle, side. And if we were going to prove it by side, angle, side, we would have to know that angle B was congruent to angle D. Okay. Next one, triangle CDE is congruent to triangle FGH. So when we're doing this problem, the first thing everybody should do is draw. Okay. There's no need to stare at it and have no idea what's going on. Okay. You don't necessarily need to draw it if you get what's going on, but if you don't get what's going on, you should not just leave it blank or stare at it. Because if you draw it, it makes the problem much, much simpler. So let's draw it. C, D, E, and F, G, H. Okay, we know they're congruent. So we know this side, CD is congruent to FG. We know GH is congruent to DE. And we know CE is congruent to FH. We also know that angle C is congruent to angle F. That angle D is congruent to angle G. And that angle E is congruent to angle H. Okay, then let's see. The measure of angle G is x plus 17. The measure of angle E is 19 minus x. The measure of angle H is 27 minus 2x. Okay, and then it says GH is 39. And it wants us to find DE. So again, if you just looked at that problem, it may look very difficult. I'm sorry, GH is 39 minus 3x. So it's a little more difficult than, yeah, okay. That makes more sense. Otherwise, this would have just been 39 and that was it. Okay. So we know DE is going to be congruent to GH, right? DE is congruent to GH. Okay, so we know DE is equal to GH. So we know that DE is going to be equal to 39 minus 3x. Okay, so in order to find DE, we're going to have to find x. Okay, so we have to look and see if we know of anything else that we can set equal to each other or add up to something. And if we look at angle E and angle H, we know angle E and angle H are congruent. Write it the other way. Angle E is congruent to angle H. So we know the measure of angle E is equal to the measure of angle H. The measure of angle E is 19 minus x. The measure of angle H is 27 minus 27 minus 2x. So now we just have to solve our linear equation, and it will tell us what x is. So we add 2x to both sides. We get 19 plus x equals 27. Subtract 19. We get x equals 8. So now we can substitute in 8 for x. So DE is going to equal 39 minus 3 times 8. Okay, 3 times 8 is 24. So 39 minus 24 is 15. So DE is going to be 15. We plug in 8 here, we should also get 15, because this is 15, this should be 15, right? And 3 times 8 is 24, 39 minus 24 is 15. So DE is going to be 15. A couple more problems like that one. So again, if we draw it out, C, D, and E, or C, D, and we'll put E down here. And then we have F, G, and H. Okay. So again, we know these sides are congruent. And CD is congruent to FG, DE is congruent to GH, FH is congruent to CE, angle C is congruent to angle F, angle D is congruent to angle G, and angle E is congruent to angle H. Let's fill in what we have. The measure of angle G is, that's the one we just did, right? Hold up. Oh yeah, that is the one we just did. Okay. So it's going to be RS and T and X, Y, and Z. Okay, the measure of angle R is 11x minus 1. Measure of angle X is 9x plus 5. RT is 7x plus 5. And they want us to find XZ. So again, We know angle R is congruent to angle X, so we know 11x minus 1 is going to equal 9x plus 5. So minus 9x, we get 2x minus 1 equals 5. Add 1. 2x is going to be 6. X is going to be 3. So we know RT is congruent to XZ. Therefore, RT, the distance between R and T, is going to be, oops, it's the same thing, XZ. So we know 7x plus 5 is going to equal XZ. Sorry, I'm trying to go a little quicker. Okay, we know x is 3, so we're going to do 7 times 3 plus 5 is xz. 21 plus 5 is xz. 26 equals xz. Next one. Okay. So again, we know all these sides and angles are going to be congruent. Okay, it's going to be J, K, and L. Then M, N, and O. And it doesn't matter what order you put them in, as long as you're putting them in the same order on each one. So if we did J, K, L, we would have to have done M, N, O. If we did J, K, L, we would have to have done M, N, O. So as long as they're lining up based on what the name is. Okay, K, measure of angle K is 3x plus 7. The measure of angle N is 2x plus 24. The measure of angle L is 5x minus 42. Sorry, I'm writing those small. I hope you can at least hear me, though. 3x plus 17, 5x minus 42, and 2x plus 24. And then the measure of angle O is 4x minus 25. And they're asking to find the measure of angle M. Okay. So we're probably going to have to find x. So let's just take our top two ones. So 3x plus 7 is going to equal 2x plus 24. Right? The measure of angle K is going to equal the measure of angle N. We got to solve it. So minus 2x. X plus 7 equals 24. Minus 7 from both sides. X is going to be 17. So now we can substitute in 17 for angle N. So the measure of angle N equals 2x plus 24. So it's going to equal 2 times 17 plus 24, which is going to be 34 plus 24, which is going to be 38, 48, 58. Okay, so that's the measure of angle N. The measure of angle O is going to equal 4x minus 25. So that's 4 times 17 minus 25. 4 times 17, so that's 34 times 2, which is 68. Minus 25, which is going to give us 63, 53, 43. Okay, so again, if we draw our triangle again, without the mess, we have N, O, and M. We know the measure of angle O is 43. The measure of angle N is 58. So the measure of angle M, this is all over the place. Measure of angle M is going to plus 58 plus 43 is going to equal 180. Okay. So then 58 and 43 is going to give us 61 plus 40 is going to give us 101. Subtract 101 from both sides. The measure of angle M is 79. Wait, sorry, it is, yeah, 79. Okay, so 79 plus 58 plus 43 should give us 108. I rushed that one a little bit because the bell's about to ring, and I want to get one more done before I end the video. So the next problem is asking us to find the measure of each angle. Okay. So again, if we make the triangle ABC, okay, we're going to have x 1.5 x plus 15, 3.5 x minus 15. Okay. So we know the measure of angle A plus the measure of angle B plus the measure of angle C is going to equal 180. So we know x plus 1.5 plus x plus 15 plus 3.5x minus 15 equals 180. Okay, combine like terms. 3.5 and 1.5 is 5. 5 plus 1x. 5x plus 1x is 6x. 15 minus 15 is 0. Divide by 6. X is going to be 30. Wants the measure of each angle, so we have to substitute it in. So we have 30. We have 1.5 times 30 plus 15. And 3.5 times 30 minus 15. 1.5 times 30 is 45. 45 plus 15 is 60. Okay, 3.5 times 30 is going to be 90 plus 15, which is 105. 105 minus 15 is 90. Right, and just to check our answer, 30 plus 60 plus 90 equals 180. Right, the last several ones on here I'm going to do on the next video when I do the review that we do on Friday. So I will add these problems onto that video because I ran out of time here. Okay, I got to go to the library for tutoring. So we'll do these on the next video.